Hello Year 10 and welcome to the second lesson on Unit 1.7 thirds. Today we're going to be learning how to rationalise a denominator. Before we start the lesson, I'd like you to recap by answering these questions on fractional and negative indices, simplifying thirds, which is what we did last lesson, more difficult indices questions from the previous unit, the previous two units actually, and then back to the first unit 1.1 on product law. Pause the video, try those, and when you're ready, play the video for me to go through the answers. Okay, if we start with question 1. Two to the power of negative 3 is 1 over 2 cubed, which is 1 over 8. The next question, 8 to the power of 4 thirds would be the cube root of 8 to the power of 4, the cube root of 8 is 2, and 2 to the power of 4 is 16. The next question, 64 over 125 to the power of negative 2 thirds. We're going to deal with the negative first and find the reciprocal. 125 over 64, and then I'm going to raise that to the power of 2 thirds. So the cube root of 125 over 64 squared. The cube root of 125 is 5, the cube root of 64 is 4, and 5 squared is 25, and 4 squared is 16. Okay, moving on to the simplifying questions, simplifying the third. So root 18 is the same as root 9 root 2, which is 3 root 2. Root 28 is the same as root 4 root 7, which is 2 root 7. Root 27 is the same as root 9 root 3, which is 3 root 3. And 6 root 108 is the same as 6 root 36 root 3, which is the same as 6 multiplied by 6 root 3, which is the same as 36 root 3. Now, these questions over here, expressed as a power of 2. 32 multiplied by 16. And 32 is 2 to the power of 5, 16 is 2 to the power of 4. Add the powers, 2 to the power of 9. 4 multiplied by 16, well that's 2 squared multiplied by 2 to the power of 4, which simplifies to 2 to the power of 6. 4 over 16 is the same as 2 squared over 2 to the power of 4. Subtract the powers, 2 to the power of negative 2. And the last question down here. Orla picks a 4-digit even number. The first digit is greater than 6, the second digit is half of the first digit, and the third digit is less than 6. How many different numbers could she pick? Right, well the first digit is greater than 6, so that could be 7, 8 or 9. The second digit is half of the first digit. Now, if obviously this is a digit, it's a number, so it has to be a whole number. So if we halve 7, we get 3.5. If we halve 9, we get a 4.5. The second digit has to be 4, because it can only be a whole number, which means that the first digit has to be 8. The third digit is less than 6, so it could be 0, 1, 2, 3, 4, or 5. And because it's an even number, the fourth digit can be 0, 2, 4, 6, or 8. As the first number we've got one option, the second number we've got one option, the third number we've got 1, 2, 3, 4, 5, 6 options, and the fourth number we've got 5 options. 1 multiplied by 1, multiplied by 6, multiplied by 5 is 30. There are 30 different numbers you could choose from. If you found that difficult, go back to lesson Unit 1.1 and revise the product rule. Moving on. Okay, today we're looking at rationalising a denominator. So we should know that denominator is the bottom part of the fraction, the top part being the numerator. We should know from last lesson what a rational number is. It's a number that can be written in the form m over n, where m and n are integers. But what we really want to focus on here is the fact that the denominators are thirds, and therefore they're irrational at the moment in these two questions. So I want to make the denominators rational. I don't want them to be thirds. So what we do for this is we make equivalent fractions. We want them to be the same value, not going to change the value of the fraction, but we're just going to rationalise it. Now, what could I multiply the square root of 5 by to make it into a rational number? Well, what would happen if I multiplied it by root 5? Well, root 5 multiplied by root 5 would be root 25, and the square root of 25 is 5. So that is how I could rationalise it. But of course, because we want it to be equivalent, we want it to be the same value, I must do the same to the top as I do to the bottom. So what I'm going to do is, in fact, I'm going to do this on a paper. It will be much neater for us. So the first example here, 3 over root 5. I want to rationalise it. So I'm going to say 3 multiplied by root 5 over root 5 multiplied by root 5. Remember why I've multiplied by root 5 on the top and the bottom. 3 multiplied by root 5 is 3 root 5. Root 5 multiplied by root 5 is root 25. So 3 root 5 over 5. The numerator is irrational, that's a third, but that's fine. We wanted to rationalise the denominator. This fraction here still has exactly the same value as this fraction here. Now you'll notice, if I put 3 over root 5 on my calculator, 3 over root 5, and press equals, it actually rationalises it for me automatically, and it's got the same answer there. The second example, 3 over 2 root 5. Look at the denominator. Which part of the denominator is irrational? What do you think I should multiply by here? Well, I'm going to multiply by root 5. Three multiplied by root 5 is 3 root 5. 2 root 5 multiplied by root 5 would be 2 root 25, which would give me 3 root 5 over 2 multiplied by 5, which is 3 root 5 over 10. Okay, let's see if you guys can have a go at some of those questions. Pause the video and have a go, and then play with the video when you're ready for me to go through. Try these two. Okay, 10 over root 5. So I'm going to say that's the same as 10 multiplied by root 5 over root 5 multiplied by root 5, which will give me 10 root 5 over root 25, which would give me 10 root 5 over 5. Now notice that we can actually do 10 divided by 5. So if we had 10 root 5s and we divide that by 5, we'd have 2 root 5. So there's our answer. The next one, 3 over 2 root 6 equals 3 multiplied by root 6 over 2 root 6 multiplied by root 6. That would give us 3 root 6 over 2 root 36, which would be 3 root 6 over 2 multiplied by 6, which is 3 root 6 over 12, which can be simplified because 3 and 12 are both divisible by 3, which would give us root 6 over 4. Right, have a think about these questions, A, B, C or D. Pause the video while you think and play the video for each question when you're ready for me to tell you the answer. So here we've multiplied by root 3 and root 3, which would give me 2 root 3 over root 9, which would give me 2 root 3 over 3. Here we've multiplied by root 5 and root 5, which would give me 5 root 5 over root 25, which would give me 5 root 5 over 5. Here we've multiplied by root 3 and root 3, which would give me 9 root 3 over root 9, which would give me 9 root 3 over 3. Here we'd multiply by root 5, which would give me root 10, over root 25, which would give me root 10 over 5. If we multiply by root 3, I would get 10 root 3. Whoops, that's terrible. 10 root 3 over 2 root 9, which is 10 root 3 over 2 multiplied by 3, which is 10 root 3 over 6, which can be simplified to 5 root 3 over 3. So the answer is D. Right, hopefully you understand that. In order to be more confident, work through these questions, go down the left, then the middle, then the right hand side, and play the video when you're ready for the answers. Off you go. Here are your answers. If you have made a couple of mistakes, that's fine. Go back and try the question again until you get the correct answer. And if you're really not sure, ask your teacher or come and ask me. Right, hopefully you're reasonably confident on this. I want you to try some of these questions, well, all of these questions, 16, 17 and 18. When you're finished, play the video, I'll show you the answers, and then I'll go through the solutions so you can just listen to the solutions for where you made mistakes. Off you go. Here are your answers. Okay, first of all, a reasoning problem-solving question. Ben types 1 over root 7 into his calculator. His display shows root 7 over 7. Show that 1 over root 7 equals root 7 over 7. 1 over root 7. This is a show that question. So any show that question, if in doubt, do more working out than you need to. You need to be really clear and not miss any steps out. So that's the same as 1 multiplied by root 7 over root 7 multiplied by root 7, which is the same as root 7 over root 49, which is the same as root 7 over 7. Question 17. The area of a rectangle is 20 cubic centimetres. the length of one side is root 5. I always find it helpful for most questions. Excuse me. To do a little sketch. So let's say that's x, because we don't know that length. And this length is root 5. Work out the length of the other side. Give your answer as a third in its simplest form. So the area is root 5 multiplied by x, and that equals 20. So root 5x equals 20. Let's solve this. Well, we want x to be the subject, so we'll divide both sides by root 5. 20 over root 5. And the question says, give your answer as a third in its simplest form. Well, let's rationalise that. We multiply the numerator and the denominator by root 5. And we'll get 20 root 5 over 5, which simplifies 20 divided by 5 is 4 root 5. Excellent. Let's try question 18. Work out the area of these shapes. So we're going to multiply the length by the width. 3 over root 2 multiplied by 1 over root 6. It would be 3 multiplied by 1 over root 2 multiplied by root 6, which is 3 over root 12. Now let's simplify our denominator. 3 over root 4 root 3, which is 3 over 2 root 3. It also says that we want to rationalise our denominator. So if we multiply by root 3, we end up with 3 root 3 over 6, and then simplify that, root 3 over 2. Divide the numerator and the denominator by 2. Next question I'm going to do is here. 4 over root 7 multiplied by 4 over root 7. 4 multiplied by 4 is 16. Root 7 multiplied by root 7 is root 49. That would give me 16 over 7. Question C. That was B. C. 10 over root 2 multiplied by 3 over root 8 equals 10 multiplied by 3 is 30. Root 2 multiplied by root 8 is root 16. That would give me 30 over 4, which is 15 over 2. What have I done wrong here? I've made a mistake, haven't I? The first two shapes were rectangles. This shape's a triangle, so I should have also multiplied by a half. 1/2 times base times height. So I'm going to change a step here and here, which would give me 15 over 4. Brilliant, we've come to the end of the lesson. You've all done fantastically for getting this far, and I will see you next for Unit 2.